Hello students. In today's session, we shall see what do you mean by TCP connection state modeling. As you all are aware, we have already studied the different transport service primitives and Berkeley socket service primitives. The TCP connection finite state machine has more states than the simple service primitives that we have seen in our initial lectures. So there are approximately 11 states under TCP connection state modeling. So those 11 states are closed, listen, sync received, sync sent, established, fin wait 1, fin wait 2, time wait, closing, close wait, and last ACK. So what is closed state? There is no connection which is active or pending. So TCP, as you know, it is trying to establish a connection between a sender and a receiver. So when it is present in the closed state, that is the TCP connection is present in the closed state, it implies there is no active or pending connection. When we go on to the listen state, the server is waiting for an incoming call. That is the meaning of listen state. Sync received implies a connection request has arrived. To whom? To the server, and we are waiting for the acknowledgement. Sync sent, the application has started to open a connection. Established state is nothing but the normal state where the actual data transfer takes place between the sender and the receiver. Fin wait 1 status, the application has said it has finished. Fin wait 2 means the other side. Okay, that is the server side has agreed to release. Time wait state is basically a state where the connection waits for all packets to die off, so that when a new connection is established, old packets are not carried forward. Closing state, both sides have tried to close simultaneously. Close wait state is nothing but the other side has initiated a release. And last ACK means wait for all packets to die off. I know these states when described here are quite theoretical, but to make it much more simpler, the pictorial representation of TCP state diagram is shown here. So before going to the pictorial representation, let us see the process that is followed. So there are 11 states as we have described, and some of these events are legal. Corresponding to every legal event, an action may be taken, but if some other event happens, then an error gets reported. Note that each connection is always in the closed state initially. Very important point, whether it is TCP or UDP, the initial state will always remain closed state. It comes out of this state when it does either the passive open, which is the listen state, or an active open, which is the connect state. Do not worry, diagrammatic representation is in the upcoming slides. So first state will always be a closed state before a TCP or UDP connection takes place. Next is either there will be a passive open state, which is the listen state, or an active open state, which is the connect state. A connection is established if the other side does the opposite and the state becomes established. Okay, so both the client and the server must come on a common ground and must agree to send and receive the data, which will only happen if the connection is established. When both the sides initiate a connection release, that is when the data transfer has taken place, there is no more data to be transferred, and both of them are in an agreement to release a connection, the connection is terminated and the state returns to the closed state. So now let us see this process in the form of a diagram. This is nothing but a TCP connection state modeling, or it is also called as TCP state transition diagram. I'll show you a colored representation of this diagram in the next slide so that the explanation becomes simpler. So as you can see, this is your TCP state transition diagram where there is color for better visualization and understanding. As I told you, the first state that the TCP or UDP connection is going to be present is the closed state, which is indicated in your orange color box. So you can see over here, whatever connections are present on top of the established state represents connection establishment process, and whatever connections are present below the established state represents connection termination process. The blue lines with an arrow are the server part or server side, whereas the red lines with an arrow, they indicate the client part or the client side. Although this TCP state transition diagram looks a bit complex, let us try and understand this particular diagram, which is simple to understand. So the first part is initially both are in the closed state. The connection is in the closed state. So in that case, what is the first step that is going to happen is the server, it was initially in the closed state, now moves to the listen state. As you can see, it is mentioned over here. Now once the server or the sender path is moving from the closed to the listened state, the client or the receiver path immediately moves from the closed state to the sync send state. So as you can all see over here, server has moved from closed to listen and the client has moved from closed to sync send state. Now what is going to happen? This is basically the client which is trying to connect with the server. That is why we have got connect /syn. Okay, so connect is basically the state and syn, it is basically trying to connect with the server. So the moment the client moves from closed to sync send state, the server or the sender path moves from the listen state to the sync received state. So you can see over here this sync which was present at the denominator now goes on the other side of the server at the numerator. So we have got sync / sync plus acknowledgement. Now the server or sender path is present at the sync received state, and the client or receiver part is present at your sync send state. Now your sync plus acknowledgement, which is present at the server side on the denominator, what happens? It comes on the client or the receiver part at the numerator, that is sync plus acknowledgement. And the moment the client or the receiver path comes from the sync send state to the established state, this acknowledgement at the denominator comes over here. That is the acknowledgement at the numerator, and at the denominator we do not have anything, and that is why it is mentioned as dash. So now the server or sender path also comes to the established state. So see the flow for the server or sender path from closed to listen. Immediately when the server or sender path moves from closed to listen, the client or receiver path moves from closed to sync send state. When the client or receiver path goes to sync send state, the server or sender path moves from the listen state to the sync received state. The moment the sender or server path is present at the sync received state, the client or the receiver path moves from the sync send state to the established state. And finally, the server or sender path from the sync received state comes to the established state. Now when both the server and the client, that is the sender and the receiver, are present at the established state, data exchange occurs. That is, sending and receiving of data occurs between the client and the server. Now, once entire data exchange has taken place, the client or the receiver path initiates the close state and moves to fin wait 1 state. The moment the client or server path initiates close / fin state, the server or sender path initiates fin. As you can see here, fin was at the denominator. Now it has come to the numerator / acknowledgement state. So the moment the client or receiver path initiates close state and comes to fin 1 state, the server or sender path moves from the established state to the close wait state. Now, what is the next step that takes place? This acknowledgement, which was at the denominator, now goes to the numerator. The acknowledgement present at the denominator of the server or sender path now comes to the numerator of client or receiver path, and the client moves from fin wait 1 state to fin wait 2 state. Now when this happens, the next step that basically happens is the server or sender path basically moves from close wait state to last ACK state. Now in this case, ACK / which is the client or receiver path, from fin wait to state moves to time wait state. So as you can see, what has happened over here is ACK, which was present at the numerator, now is present at the denominator. So what happens over here is, when the client or receiver path moves from fin wait 1 to fin wait 2. So over here, the server or sender path moves from closed wait to your last ACK. And this ACK ultimately makes the sender or receiver come to the closed state. But the client or receiver doesn't come directly to the closed state, students. You can see from fin wait 2, it could have directly come to the closed state, but it comes to the time wait state. It waits for a certain amount of time, and then only there is the closed state that the client comes to a conclusion. Now, what is the significance of this time wait state? The time wait state over here, as you can see, represents timeout. So, the client or the receiver path, after coming to the time wait state, waits for a range of 30 seconds to 2 minutes. Now, why does it wait for this? There is a reason. It helps, the time wait state helps to clear out any old packets in the network, prevents them from interfering with the new connection. Now, when the client and the server are just about to execute in the closed state, the client waits for a timeout period of 30 seconds to 2 minutes to only ensure if there are any old packets, they can be cleared out before moving to the closed state. For a simple reason, if a new connection gets established, then these old packets should not interfere in this new connection. That is why the client or the receiver path waits for a duration of 30 seconds to 2 minutes in the time wait state, and if there are no old packets in the network, it moves to the closed state and the connection terminates. So this is the simplified explanation of TCP state transition diagram or TCP state modeling. Thank you.